A reflection is a type of geometrical transformation, which is where a function is altered in a certain way. And for a reflection, the graph is flipped about one of the coordinate axes, which is like the y or x axis, and its orientation changes, but the size of the graph stays the same. And a particular reflection, you say, is flipped over the y or x axis using an equation like y equals 0 or x equals 0, where y equals 0 will be the x-axis, and x equals 0 will be the y-axis. So here, in the first graph, let's say the black line is the original function. When we flip it over y equals 0, or the x-axis, this is a reflection, and the red line is what you get after reflecting it over the x-axis. And here is the same. The black line is the original function, and the red line is the resulting graph after flipping it over the y-axis, or x equals 0. And the first type of reflection is a horizontal reflection, which is the reflection over the y-axis. And if you have a function y equals f of x, then after you reflect it over the y-axis, it's going to become y equals f of negative x. You can see here that the changes in the points are that the x values change, where the sign flips. You can see that this point, 3 comma negative 3, turns into negative 3 comma negative 3 on the reflected curve. So the x value changes as the sign flips, and the y values stay the same, because the negative 3 stay the same, and there's no change done to the y values. So basically, if you have a point x comma y on this graph, then that point's going to turn into negative x comma y on the reflected graph. And you can see that through all the points I've labeled, 3 comma negative 3 turns into negative 3 comma negative 3, 1 comma 0 turns into negative 1 comma 0, and 0 comma 1 turns into 0 comma 1, because points on the y-axis have x value of 0, and they stay the same. And horizontal asymptotes, we don't have any in this graph, but if you have a horizontal asymptote x equals k, let's say it's like right here, then on the reflected graph, it would be x equals negative k, like right here. So asymptotes are flipped as well on horizontal reflections. The second type of reflection is a vertical reflection, which is a reflection over the x-axis. And in this one, if you have y equals f of x, and then you reflect it over the x-axis, or do a vertical reflection, then your resulting graph will be y equals negative f of x. And for all the points, let's look at this point. 3 comma negative 2 turns into 3 comma 2. And when you do vertical reflections, the x value stays the same, but the y value switches signs. And it's like the opposite of the the horizontal reflections. So if you have a point x comma y, it turns into x comma negative y on the reflected side. And every single point on the x-axis stay the same, similar to how on horizontal reflections everything on the y-axis stays the same. You can see that the points negative 2 comma 0 and 0 comma 0 stay the same on the reflected side. And here, asymptotes are reflected as well, but instead of vertical asymptotes being the ones that change, it's horizontal asymptotes. So let's say you have a horizontal asymptote at y equals k. Then when you reflect it, it turns into horizontal asymptote at y equals negative k. And now let's get into some practice problems. If you think you can do this one, then pause the video and try it. In this one, we're given the graph of y equals f of x, and we're asked to sketch y equals negative f of x. And when y equals f of x turns into y equals negative f of x, that means we've done a vertical reflection or reflection over the x-axis. So first, let's draw our graph. And when we do a vertical reflection, as I said, all the x values stay the same, but the y values switch in sign. And we're given 2 points here, so we know that one of the points is going to be negative 1 comma negative 5, and the other one's going to be 3, 3. So like right here and right here, approximately. And I know this because every single point, the x value stays the same and the y value reflects in sign, and I just took the points from the original graph. So what we can do is just look at every single part of this graph. It starts as a negative, and then it goes into the positives, right here and here. And since in a vertical reflection the signs change, we can say that it starts in the positives and then goes into the negatives. And then it crosses this point, which will reflect down here. So we can draw it like that. And the first half of the graph is complete, but we need to label the point at -1, 5, or -5, as that's the point that's flipped from -1, 5. And then the graph goes up to cross 3, 3, and then goes back down. So this is approximately what our new graph is going to look like after it's reflected. It doesn't need to be exact, but remember to label the reflected points. Here's 3, 3 from 3, -3. And yeah, this should be your final answer, something similar to this. And now let's do another practice problem. If you think you can do this one, pause the video and try it. For this one, we're given the same y equals f of x, but this time we're asked to sketch y equals f of -x. And this is a horizontal reflection, or reflection over the y-axis. And whenever you reflect something over the y-axis, instead of the y values changing, the x values are going to change. So we can label our points -1, 5, turning into 1, 5, and 3, -3 turns into -3, 3, or -3, -3. So there's going to be a point right here and right here, approximately. And so we can just flip the graph over, starting from this side, and it starts at the positives and then goes down, goes up, and then down again. So let's draw the same thing, but just reversed into the -x side. So starts in the positives, goes down, touches our point at -3, -3, instead of 3, -3, goes up, crosses right here, which is this point reflected over, and then crosses the y-axis, and all the points on the y-axis are unchanged, so this should be at the same spot. And then goes up, crosses -1, 5, and then goes down. But instead of -1, 5, for us it's going to be 1, 5 on the reflected side. So now you have your answer. It's not exact, kind of like last problem, but this is approximately what your graph should look like. And 2 points at -3, 3, at 1, 5, and you can look at your points on the y-axis and the x-axis to make sure everything lines up. Remember, the x-axis just flips over like here, and this could go like here, and that matches up with what we did, and the points on the y-axis stay the same. So yeah, this should be your final answer. So everything that I explained in this video and all the problems that I went through should teach you everything you need to know about reflections of graphs and what they are. If you learned something from this video, or if you enjoyed it, please consider liking and subscribing.